Good morning, everyone. So today we're going to talk a little bit about random sampling because we've spoken a lot about what isn't random sampling, but we haven't seen a whole lot of ways that you actually can do a random sample. So this is one example right here. You can use a two-dimensional grid. Now, we're going to talk a little bit about how we can do that for almost any situation that we could even possibly have. But for now, we're going to use this situation. Let's say we've got a 64-acre coconut farm, and it's arranged in an 8 by 8 array, like this one. Mika wants to know the average number of coconut palms on each acre, and each cell on the table represents an acre of land. And the number in each cell tells you how many coconut palms grow on that particular acre. So, looking at this situation, it's like Mika owns this enormous 64-acre, 8-acre by 8-acre coconut farm. And she's trying to figure out approximately how many palms grow on each acre of land. So the numbers in green represent Mika's 10 random represent Mika's random sample of 10 acres. And we want to know the average number of coconut palms on the randomly selected acres. So now, what's a good measure of average? Do we think it should be mode for this one? Let's see, we've got a 36, and no two of the others, I think, are the exact same number, so I don't think mode is a very good indicator because it only applies to 2 out of the 10 samples. And let's see, the lowest one is 30, the highest one is almost twice as many. So, I mean, median might work. I'm going to say mean is best for this one. And by the way, when you answer yours, they're going to want you to use mean also. So if I first figure out what all of the number of palm trees from all 10 random samples is put together, I'll get 50 plus 30 plus 36 plus 46 plus 40 plus 36 plus 55 plus 32 plus 58 plus 48. I personally decided to add them up 2 at a time to get 80 plus 82 plus 76 plus 87 plus 106, which I then turned into 162 plus 163 plus 106, which then became 325 plus 106, which together is 431. But don't forget, we are doing means. There's one more step. We need to divide by 10, because that's our number of inputs. And when we divide all of them by 10, we'll get 43.1. By the way, this example, don't write it down. This is just to show you. Now, granted, this is a convenient situation. Somebody's got a perfectly square grove of palm trees, right? Most real-world situations won't be quite as easy to put into a grid. But even if we were doing something like, if we asked 100 people their shoe size, and taking the mean of those 100 people, we didn't answer right away, right? So instead we took a sample of our sample. We could arrange those 100 answers into a 10 by 10 grid like this one. And even if it was something like 96 people, we could use a rectangular one and say 4 by 24. Or we could still use a square sample and just leave 4 spaces blank. And then you could say, hold a marker about a foot above it, right? And then drop the marker and see where marks landed, and you could use those for your random samples. This is just to show you one of the ways we can actually make a real random sample in a real world situation. Now we're about to get to the part that you should write down. Very short actual written portion today. So we've got one means of random selection. Take all known values, organize them on a two-dimensional grid, usually a square or rectangle, And you can drop an object that will mark a selection for each measurement. You could use a marker, you could use 2 dice, that kind of thing. And on generalizing, option 1, which is the only one that we're going to be using today, use the mean of the sample and multiply times the applicable proportion to approximate a mean for the population. Thank you.